All right, so let's take a look at number 35. All right, 35 had this problem. It had 70 over 61 divided by 21 1/22 minus 55 thirteenths. Okay, those all look very ugly. All right, order of operations tells us I have to do this division first. So they're already in improper fractions, so I'm going to go ahead and leave my first fraction exactly how it is. I'm going to change my division to multiplication, and I'm going to change that second fraction to its reciprocal, and then I'm just going to show minus 55 thirteenths at the end. All right, so that's the first part. All right, I'm hoping, and I'm pretty sure this is the case, that I can divide out a 61 from the 122. And I'm going to check that because that would make life like considerably easier. All right, so 122 divided by 61, no, hang on, 122 divided by 61 is 2. So that makes life easier. If you're not sure, just try. All right, I know 70 divided by 7 is a 10. I know 21 divided by 7 is 3. So now I'm just going to multiply. So I have 10 times 2, which is 20, over 3 times 1, which is 3, minus 55 thirteenths. So I've done my division. Addison, are you good with that? Okay. So now I have to do this subtraction. Well, to come up with a common denominator, I'm just going to multiply 3 times 13, which is going to give me 39. So my common denominator is just going to be 39. I'm not going to mess around with trying to find a common factor. I'm just going to multiply them together. All right, so I have 20 thirds, and I have to multiply that by 13 over 13. So 20 times 13 is going to give me 260 39ths. So this is now 260 39ths minus, well, I have 55 thirteenths. I have to multiply that by 3 over 3. So 55 times 3 is going to give me 165. So that's 165 39ths. So I'm going to put this back in. So I have minus 165 39ths. Now I'm just going to do that subtraction. So minus 260. And this is going to give me a positive 95 39ths. All right, I am okay with you leaving that as an improper fraction only because some of your givens were improper fractions. But when in doubt, change it into a mixed number. So I have to do 95 divided by 39. All right, well, 95 divided by 39 is going to give me, this goes into it twice. So 39 times 2, that's going to give me 18, that's 78. So I have a 1, 7. So that now becomes my numerator, that remainder. So this is 2 and 17 39ths. Addison, does that help you? Awesome. Cullen? Yeah, are you good with this? Okay. Does someone have a question on this? On this one? All right, 28? Cullen, 28?
Yeah.
Okay, so let's take a look at 28. Okay, so they give us this drawing to kind of help us get a visual of what they're talking about. So they have this, it says you want to cut bookmarks that are 6 inches long and 2 2/3 inches wide from a sheet of decorative paper that is 13 inches long and 6 inches wide. So here we have this piece of paper. It's 13 inches by 6 inches, and we want to cut these into pieces that are 6 inches long, but they're 2 3/8 inches wide each. How many of you guys are cool with what the situation is? Okay. So then it says, if you cut the bookmarks as shown, what is the maximum number of bookmarks that you can cut from the paper? So we want to find the maximum number of bookmarks. All right. Whether I have fractions, whether I have decimals, whether I have whole numbers, this width of each sheet is a rate of each bookmark. This width is a rate. It's a certain number of inches per bookmark. And if I cut all of those up, when I cut them all up and put them together, they're going to equal that 13, or the total length of that sheet. All right, so my number of inches per bookmark, that is a rate. I'm going to multiply that by my number of bookmarks. That's going to give me the total length or width, I don't care what words you use, of the sheet. So how many of you guys are cool with that game plan? All right, don't freak out that these are fractions. Forget about the types of numbers they are. Just think about the information they've given you. They've given you the width of each bookmark. That's a rate. If I multiply that, I have to. That's a rate per the inches per bookmark. I always multiply that by my number of bookmarks. That's going to give me the total length of all of them. All right, so now I'm just going to put my numbers in. Well, the rate, the inches per bookmark is 2 3/8. I don't know my number of bookmarks. There is my x, and it's going to be equal to 13 inches. So, Cullen, are you good with that so far? Okay. Questions on that game plan? This is a very, I don't mean easy. I just mean simple, means not complex. This is a very simple story problem where you have a rate, you have a total of whatever it is you're measuring. This is total number of inches. And you are looking for the total number of things you're multiplying that rate by. This is a very basic one. All right, so please make sure you recognize when you have rates. All right, so now I have to do my improper fraction work because I have to multiply with this. So 8 times 2 is 16 plus 3 is 19. 8 times x is equal to 13. To get rid of that multiplication by that fraction that's our coefficient, I multiply by its reciprocal. All right, this is not pretty because I can't divide out common factors here. So I have x is equal to, all right, so I have 13 times 8. This is going to be 104 divided by 19. Now I'm going to do this division. So I have 104 divided by 19. 19 divides into 104 5 times. So that's going to be 45. Carry the 4. That's going to be 95. And I end up with a 9 as my remainder. So this is 15 9/19. So my x is equal, not 15, 5. 5 9/19. There's my actual math answer. So the question was, what is the maximum number of bookmarks that I can make? All right, so for us to have a maximum number of bookmarks, do I round that up to 6 bookmarks, or do I leave it as 5 bookmarks? Addie? Why? Well, what don't I want? Do I want 9/19 of a bookmark? I don't. So what does that mean about that paper? It can only make 5, and we have some left over. Tina, you're listening to me. Patrick, you're listening. So that 9/19 means that we're going to be throwing some paper away, aren't we? Just a little bit of paper. So this means that we can make up to 5 bookmarks. Yes. Can I finish this? Cullen, does that help you?
Yeah, I rounded up and said that.
Oh, you have to make sense of how to round it. Okay. All right. 36 we are going to do tomorrow. I'm not doing it today because I need to move on. I will do it tomorrow for you. Okay? So put this away, get your notes out. Okay. So today is the 23rd. So you guys, I want you to remind me, I'm going to put a little note here to remind myself, but let's definitely do number 36 tomorrow. Because I don't think you're going to have a ton that I'm going to need you to do, that you're going to need me to do from tonight's homework. I think tonight's homework should be relatively easy. Okay. All right. So today is the 23rd. We are in 5.6. So we're going to use, and I'm going to use a different phrase than they're using. What they say is use multiplicative inverses to solve equations. All right, that's a really fancy term, this multiplicative inverses. All this means is we're going to use multiplying by the reciprocal of coefficients to solve, which is what we were doing yesterday. So this is not new stuff for you. We're just going to practice more of it. So we're going to use multiplicative inverses, which is just multiplying by the reciprocal, or the inverse. Reciprocal and inverse are the same, of coefficients. All right, so let's take a look at a couple problems. So I have 4/7 times x is equal to negative 12. I just want to remind you, when the coefficient is a fraction, do not divide by the fraction. It's going to be too confusing. Multiply by its reciprocal. Bless you. So when your coefficient is a fraction, don't divide by that fraction. It's funky looking. It's going to get you confused. Simply multiply by the reciprocal of the coefficient. So if I have 4/7 times x is equal to negative 12, what should I multiply 4/7 by to make it a 1? Or to get rid of that multiplication of 4/7? Nico? Excellent. I'm going to multiply both sides by 7/4. Please make sure you're showing me multiplication there. When I do that, my 7/4 and my 4/7, they divide each other out, so I'm simply left with a 1x. Here I'm going to divide out common factors. So 4 divides into itself once, 4 divides into 12, negative 3 times. So now I just multiply my negative 3 times my 7, and I get a negative 21. All right, let's do another one. All right. This one's going to get a little bit more complicated. Has a little bit more to it. It's going to combine adding fractions and multiplying fractions together. So I want you guys to solve. Negative 11/15 times x plus 4/5 is equal to 1/3. What's the first thing I need to do to start solving this? Cameron? Yeah, and I'm going to say add a negative, but I agree with you. Add a negative 4/5 to both sides. Well, for us to add for us to add 1/3 and negative 4/5, or for us to do that subtraction, what do I have to do? Matthew? I do, and I'm just going to do this right here. I'm going to multiply 1/3 by 5/5, and I get 5/15. I'm going to multiply negative 4/5 by 3/3, and I get a negative 12/15ths. Nope. This should be 3. Yeah. All right. So now what I'm going to do is I have 12/15ths minus 5/15ths. And I end up getting 7/15ths. How many of you guys are good with that? You guys good with that? All right. So now I have a negative 11/15ths times x is equal to a negative 7/15ths, because my greater absolute value was the negative number. Now what? Now what? Amanda? Excellent. When I do that, those fractions on the left cancel each other out. I end up with x equals, well, I'm going to divide a common factor of 15 out. So I end up with negative 7 over negative 11, or 7/11ths. Questions on that? Okay, let's take a look at a story problem, because no one's going to walk up to you on the street and tell you to solve this. All right, so let's take a look at a story problem. All right, as you notice, we have kind of 2 steps going on here, so we have to pay attention to what that's going to look like. All right, so let's take a look here. So here's our example. I'm going to show this to you. I want you to write this information down. This stuff right here. Because it says in example 3, we're going to answer this. So write this information down. We're going to do this story problem. It says calcitites are icicle-shaped stone formations found in cave ceilings. They form from minerals deposited by dripping water. Suppose a stalactite is, say it again, stalactite, thank you. That one's a hard one. Thank you for knowing that. A stalactite is 10 inches long and is growing at a rate of 1 inch per decade. How long will it take for the stalactite to reach 1 foot? So write all that down, please, and we're going to work through this together. How many of you guys notice there's a rate up there? Awesome. So it's 1/8 of an inch per decade. All right, so here, don't race ahead. Let's talk about this together then, right now, because I want to make sure everyone's on the same page. So we know the stalactite is 10 inches long now. It grows at a rate of 1 inch per decade. We want to know how long it's going to take to be 1 foot. Okay, somebody tell me, what game plan would you come up with for this? What game plan would you come up with? Ada? So inches now, okay. Per decade, hang on a second, decade times my number of decades, okay. The new length, or the, let's say the desired length, end length, excellent, I like that, end length. How many of you guys are cool with this? Okay, so my number of decades, we don't know that, that's X. Nice job, Ada. So my number of inches now is that 10, plus, well, the rate per inches per decade is 1/8 times X equals, what should I write for my end length? Brendan? 12 inches. Why not 1 foot? Yes. I'm glad you caught that. All the rest of that is in inches, so that has to be in inches. So this is going to be 12 inches. All of you finish this, please. I'm going to do it as you're doing it. Patrick, what did you get for your answer? Okay. So I subtracted 10 from each side. I got 1/8 x is equal to 2. To get rid of that multiplication by 1/8, I have to multiply by 8 over 1. So Patrick, what did you get? What's 2 times 8? So 16. 16 what? Patrick, x is equal to 16. What does 16 represent? No, it's not inches. Go back up and look. In our story problem, you always define your variable. In the game plan, what did we say x represented? The number of decades. So explain your answer to me. Yeah, what does the answer mean, dude? Excellent. So it would take 16 decades to reach 1 foot. Or something like that. It's really important you guys pay attention to what your variable stands for, please. All right, evens, head out.